Hi, my name is Nabil,
Hi, my name is Hiba.
and today we are presenting our Capstone project, Electric Vehicle for Emergency Power System, sponsored by ZAM Engineering and Construction Services. The main problem we are trying to solve is related to cement rotary kilns. In large industrial plants, a kiln must continue rotating slowly during a power outage. If the kiln stops while hot material is still inside, heat can concentrate on one side of the shell and cause serious thermal damage or deformation.
Because of this, cement plants normally use an emergency inching drive system. However, these systems can be expensive to design, install, and maintain. Our project explores an alternative solution using an electric vehicle as the emergency power source. Our objective is to design an EV-based emergency inching drive system that can rotate the kiln at zero point 0.5 RPM during a power outage. We also need to determine whether the selected EV can provide enough torque, speed, and power while staying within a safe operating range.
For our design, we selected the Ford F-150 Lightning as the EV platform because it has high torque, a large battery capacity, and a drivetrain that is suitable for mechanical power transfer.
For the engineering design, our system uses both motors and the Ford F-150 to transfer power mechanically to the kiln. The power transfer path starts from the vehicle output shaft, then goes to the lower drive pulley, through the vertical belt system to the upper pulley, then into the gearbox, and then finally to the kiln roller shaft. From there, the roller turns the kiln shell.
Our concept used dual timing belt transmission system. Two identical belt paths are placed in parallel to increase torque capacity and distribute the mechanical load. We choose synchronous timing belt because they provide positive engagement between the belt and pulley teeth, which help prevent slipping during operation.
We also built a physical prototype to demonstrate the concept. The prototype includes the kiln shell, support rollers, a model truck, belts, pulleys, and a voltage controller. The assembly process included creating the base, assembling the rollers, wiring the controller, painting the kiln, and then adding the belts. From our final design, we identified several advantages. The system could be more sustainable than a diesel generator, reduce human interaction during emergencies, and potentially be a lower cost alternative to traditional emergency power systems.
However, there are still limitations. The system requires gear reduction, which add cost, and it also needs precise alignment between the vehicle and pulley system to avoid efficiency losses.
For future improvements, we recommend adding gear reduction between the shaft and pulley system, using larger belts and pulleys to transfer higher torque, and integrating a monitoring system to track energy consumption and runtime during outages.
Overall, our project shows that an EV-based emergency drive system is a promising alternative for rotating a cement kiln during power loss. Thank you.